Welcome to another tutorial on machine learning with Scikit-Learn. As a reminder, the data we're working on is the cancer dataset. We're doing supervised learning, and to be more precise, we're doing classification by looking for a binary answer. Is this image representative of a malignant or benign tumor? Now, you might hate this, but we need to go through a little bit of theory. So, in supervised learning, there are two major types of problems: classification and regression. In classification, we try to predict from a list of predefined choices. It can be binary, like in the cancer dataset, or multi-class, like for example, separating books into 10 categories. So we're dealing with categorical data. On the other hand, in regression problems, we're dealing with continuous data, such as predicting someone's income based on their age, education, and so on, predicting stock market prices, and predicting any kind of price, and similar problems. So far, we've used the k-neighbors classifier for our classification problem. There is also a k-neighbors regressor in Scikit-Learn, which deals with regression tasks, but we won't use it in our example, maybe in another series. Then there are linear models, which can be used for classification and regression. In short, with linear models, the prediction is made according to a linear function of the input features. There are many linear models in Scikit-Learn, but for now we're specifically going to focus on logistic regression, which counterintuitively is a classification and not regression algorithm, despite its name. Another thing to point out is that many of these machine learning algorithms can be used for both classification and regression with Scikit-Learn. So let's apply logistic regression to our cancer dataset and see how it performs compared to KNN, which, as you might remember from our previous videos, got about 94% accuracy on the test set. You can watch the previous video for that. Now, I want to repeat myself by saying that I get a lot of inspiration from Andreas Muller and Sarah Guido's machine learning book, which the link is here, and I'll also link to in the description. Now, with that in mind, let's finally jump into the code. So, logistic regression. From Scikit-Learn datasets, import load breast cancer. Okay, so we're actually doing this from the beginning to have a clean and tightly organized code. So from Scikit-Learn dataset, import load breast cancer. From Scikit-Learn linear model, import logistic regression. Now we're also gonna import train test split from model selection. Okay, now matplotlib, pyplot, splt. We're following the convention here. Now the magic command matplotlib inline. Okay, now let's instantiate the dataset, load breast cancer. Now, as you might recall, we're gonna split the data: x train, x test, y train, y test. So features train, features test, targets train, targets test, train test split, cancer data, which holds the features, cancer target, which holds the labels malignant or benign. We're gonna stratify by cancer target. Okay, and we're going to use random state is 42, as you might know, the answer to what is the meaning of life. This is for randomization. Now, this is basically similar or like almost exactly as we did with the KNN. And this type of process applies to most machine learning algorithms in Scikit-Learn. Okay, now let's instantiate our logistic regression classifier with its default parameters. Now let's fit it onto or basically train it, x train, y train, and we're gonna print its accuracy in the next cell. So we're gonna run this with Shift Enter to make sure we didn't get any errors. Shift Enter. Okay, so these are the default parameters. We're gonna talk about them in more detail in a future video. Now let's see the accuracy. So print accuracy on the training. Let's call it not set but subset. Okay. And we're going to use like 3 fixed points. Format logreg dot score, the score on our train subset. Okay, now let's do the same thing for the accuracy on the test subset with 3 fixed points. So X test, Y test. All right, now let's run this to check the accuracy. Okay, so 95.8% on the test set. That's much better than KNN, which got actually 94. Well, I say much better because even though there is a big difference between 94% and almost 96% over here. So that can make a huge difference in reality. And we only use the default parameters of the logistic regression algorithm. Once again, this basically means that in 95.8% of the images it is being provided after it is trained. So after we fit it, the algorithm can accurately predict if we're dealing with a malignant or benign tumor. The next question follows. Can we play with its parameters to optimize it for even better results on our cancer dataset? We'll find out in the next video. So if you enjoyed this one, make sure to hit that like button and subscribe. Thank you for watching.